Welcome back to Sundays Off for Science. I go by Germs. This is a segment I like to call Science Sunday, where I answer questions from viewers like you. Wishing everybody a happy Kwanzaa out there. You see I have my dashiki print on and my Africa necklace to honor Africans living in America. And this first question comes from one of my good friends, Aiden. And Aiden's question is, how can someone exhibit symptoms of an X-linked recessive mutation when they have either no familial history, that's no family history, or two X chromosomes with only one parent affected by the mutation? Very good question. Let's just get right into it. In order to answer this question, we actually have to do a little bit of genetics review. Most of you might be familiar with basic genetics, and you probably learned it in basic biology. When you talk about genetics, we're going to reference the Punnett square, is what we call it. It's this diagram here. If you look at the diagram, you can see that up top, we have two X's, which is going to represent the mother of any offspring. And then on the side here, we have an X and a Y. You may have heard that males have an X and a Y chromosome, whereas females have two X chromosomes. And so this XY here is going to represent the father of that offspring. And then these four here represent hypothetical offspring. Some combination of the mother and the father's chromosomes is going to make up one of these offspring here. The way you use this device here, it's a very simple device. And so you just draw a line across from the father and then draw a line down from the mother. And then where those meet in one box, that's what chromosomes the mom and the dad are going to give to that specific offspring. And so each of these boxes represents a possibility. It represents a possible combination of the mother's chromosomes and the father's chromosomes, where in each one of the parents can only give one of these chromosomes, and it's random which chromosome is going to be given, right? And so, as you can see down here, if you receive an X chromosome, which is the only chromosome that your mom can supply you with, and a Y chromosome from your dad, which your dad can supply both X or Y. So in turn, your dad is actually determining gender when it comes to a genetic sense. If your dad gives you an X, it's going to make you a genetic female. And then if your dad gives you a Y, it's going to make you a genetic male. So you'll have an X and a Y, because Y will always dominate over X when it comes to genetics. So if Y is present, you're going to be male. And if Y is not present, then you're going to be genetically female. So that's the basics of the Punnett square and how we determine what are the possibilities when it comes to sex determination. So now we're going to go into the next logical step of genetics, which is not terribly complicated either, but we're going to just jump right into it. And so if you look at this diagram, you have X-linked recessive inheritance. And so when we talk about inheritance, we talk about the genes that are being passed from a parent to an offspring. And so what happens is your mom and your dad each are going to give you 23 chromosomes. And so those chromosomes will combine in ratios to supply you with 46 chromosomes that you need as a human being. And so what happens is the mother and the father are going to supply certain genes. What Aiden's question is making reference to is disorders. Some disorders are what's called heritable, which means that they can be inherited from a father or a mother or both. When we're talking about heritability, we're actually talking about what genes are you getting and what chromosomes are you getting from your parents. So in this example here, you can see that there's some disorder and it's X-linked, which means that it can only be tied to an X chromosome. So fittingly, if you are a male and your dad is the carrier of that disorder, then you will not get that disorder, because if you are a male, your dad is only supplying a Y chromosome and the disorder is actually on the X chromosome. However, that's assuming that your mom has two normal genes. Then the son will be unaffected. However, if the dad has a daughter, his daughter is 100% gonna be a carrier of that disorder, because the dad can only give an X chromosome. And so the daughter's going to be a carrier, However, there's a safety net because the mom has 2 healthy X chromosomes, so she's going to give the daughter one of these healthy X chromosomes. Under normal circumstances, the daughter will not express that disorder. There is a small chance you can have this other scenario here, where you have a father who is not a carrier of that gene, and that's the term we like to use, a carrier of a gene, for a parent that has that gene and it doesn't physically manifest. And you can go your whole life without ever knowing that you have that gene because it never manifests unless you did some sort of genetic testing, or if you had an offspring who had that disorder, then you could backmap and find out that you were in fact the carrier of it, or that the mom was a carrier of it. So let's look at the second scenario. So in the second scenario, we can have an unaffected father who is not a carrier of that gene, and then a mother who is a carrier. However, she's unaffected because she has that safety net. She has another X chromosome with a healthy form of that gene on that chromosome. So she is not expressing it, and she probably doesn't even know she has this disorder unless she has a family history, which Aiden alluded to in his question. So if she had a family history, then she would probably undergo some genetic testing in order to determine whether she is a carrier for that gene or not. So now you have multiple scenarios here when you have the mother who has the gene, as opposed to when we had the father who had the gene, only the daughter could get that gene. However, when you talk about X-linked mutations, the mother can give this gene to either offspring because the mother can only supply an X. And so it's a 50-50 chance whether she's going to supply this healthy X or if she's going to supply the mutated gene. If we did our Punnett square with the healthy father who's supplying a healthy X, and if the mother supplies a healthy X, then we'll end up with a normal offspring for a daughter. If the mother supplies her healthy X and the father supplies his Y, then you end up with a normal son. Here's where the disease state comes in. If you have the mother who just by chance supplies her mutated gene to either the daughter or the son, the daughter is going to be a carrier because she has the gene and she also has a healthy X chromosome that she has inherited from her dad, so she is likely going to express that healthy chromosome under normal circumstances. However, since the mom can only give an X, if she gives that mutated X chromosome to her son, the dad can only give this Y. Since he can only give this Y, there's no X to fall back on. So as a male, if you get that mutated X chromosome from your mom, you have no other choice but to express this because you have no other X chromosome to fall back on. So that's just a small overview of the genetics you'll need to understand Aiden's question and then the subsequent answer. His question, just to rephrase his question, he says, how can someone exhibit symptoms of a recessive X-linked mutation when they have either no familial history? And so let's stop there because that's the first part of his question. Is he's wondering, how can you have no family history of a disorder and then you as an offspring be the only one in your family to express that disorder? And that I just alluded to that. It's because you can have a mutated gene as a female. You can be a carrier as a female of that disorder and have that mutated X chromosome. However, it's going to be silent because you have another X chromosome to fall back on. So it can go for generations unnoticed until the mom, just by chance, just by random chance, passes that X chromosome on to her son. And then you would likely see a disease state. So that's how it can happen with no familial history. And then in very rare cases, there can just be random mutations that can cause this, but that's very rare. Then we have the second part of his question, which is 2 X chromosomes with only one parent affected by the mutation. So, and that goes straight back to the basic genetics overview that we just did. So as a female, if you have 2 X chromosomes, one healthy and one not healthy for that segment of the chromosome, which is called an allele, there are mechanisms that chooses which one of those 2 segments they're going to use. So if it notices that one of them is defective and the other is not defective, it's going to default to the not defective version of that gene. However, there are certain situations where the body does not pick up on this, and it's a very small chance that this could happen. but it does happen, and the body doesn't pick up on this mutation, so it has a missense in which it doesn't notice that it's mutated. And then there's also another case where there can be something linked to that segment of DNA that is actually worse for you than whatever disorder your body's trying to avoid. And so in that case, your body would choose the lesser of the two evils. And so it would express whichever one of those is deemed as the least lethal to the offspring. So thank you for that question, Aiden. I appreciate that question so much. And I hope you guys learned a little something about genetics. And one thing that you'll notice about genetics, if you continue to follow this podcast, is that genetics is incredibly complex. And so you always have an exception. And that's one thing I learned from my genetics instructor, was that there are always exceptions to anything, that nothing is always 100% of the time when it comes to genetics. And I wish it was that way, but it's not. Thank you again.